So for rectangular region, you learn that, hey, we can take the integral with respect to x. For x, I'm going to use a different color so you don't get confused about these. So dx, x, and then dy, y. Remember, you always have to take the integral, inner integral first. Inner integral comes first. First this guy. Then the second step is to find the outer integral. This is the second. This guy is equal to, no matter the order of integration, this is always equal to taking the double integral with respect to y, then with respect to x. It doesn't matter at all. You must get the exact same value. Now your inner integral is with respect to y. This is coming first. And then you take the integral with respect to x, which is going to be here. Here we go. And all of these are related to elementary calculus techniques integration. So this is the second. Now I expect you to ask, what if, as Grace asked, what if we don't have fixed boundaries? What if my a is bounded between two numbers, but my y is different? So when it comes to non-rectangular regions, they have two cases. Case one is the case that your x is bounded between a and b. Your x is fixed, a and b, but your y is bounded between two functions. Y is bounded between two functions that are functions of x. So here we have, for example, g of x and h of x. Then the setup is like this. Your double integral must have x outside. X must be outside. So your x, a to b, and your y is inside. So this is f of x and y, dy. You cannot change the order. Gx, hx, and x. This guy comes first, taking the integral with respect to y. It is your first integral. And then you take the integral with respect to x. Because your x has numbers, you can plug those in and get the final answer. But if your y is fixed, your y goes outside. Second case. Your y is bounded between c and b. And your x is bounded between two functions related to y. X is bounded between two functions. What are those two functions? Let us call them gy and h of y. Then your y must be outside. Your outer integral is with respect to y because it has fixed boundaries. And then inner integral is with respect to x. You write down your function dx dy. You take the inner integral first with respect to x. And the boundaries for x, gy, hy. And then you take the integral with respect to y with boundaries c to d. So this is your second integral to evaluate. Very good. Give us an example. What are you talking about? Well, so we don't need rectangular regions anymore. And so here we go. Suppose we want to find this example. To find example. What is this guy talking about? It says, let R be the region. Let R be the region bounded by, bounded by y equals to x squared and another function y equals to square root of x, and calculate the double integral of x squared times y dA. dA, it means that it doesn't mention you are taking the integral with respect to x or with respect to y. This is the area element over region R. So let me erase this part of the board. I need more space. So note that dA can interpret it as dx times dy, or dA can interpret it as dy dx. We need to decide on that. Well, so what is our very first step? Your very first step is to graph this guy. Step one. Graph the region. Okay, it's not that hard. I know this is a quadratic function and this is a radical function. I already know how to graph these two. Well, okay, this is my x, this is my y. And let's use this guy here. This is my x squared. And this guy is my square root function. So what's the region? The region bounded between these two functions. Bounded between these two functions. Okay, this is the region R. This is region. Well, I only have these two functions. Remember that. I need my x bounded between some things. But what? Step two, find the boundaries for your x. You already know your y is bounded below by x squared and on top by square root of x. Step two, find the boundaries for x. But how? Simple algebra. I set these two functions equal to each other and solve for x. Set x squared equals to square root of x. Raise both sides to the second power. You get x to the fourth equals to x. Bring x to the other side. X to the fourth minus x equal to 0. If you factor out x, you get x cubed minus 1 equal to 0. So x is 0 and x is 1. X is bounded between 0 and 1. Okay, I'm happy. I found the boundaries for my x. So now I know my x is bounded between 0 and 1, and my y is bounded between from below the smallest value that my y takes is on x squared. The maximum value that my x takes on is on square root of x. This is your lower function, and this is your upper function. Okay, so since x is bounded between 0 and 1, I decide to take the inner integral with respect to y and outer integral with respect to x. You have the double integral, x 0 to 1, and y. Again, guys, your minimum values are on y equals to x squared. So the lower limit is x squared. Your maximum values are on square root of x. So the upper bound is square root of x. What is the function? X squared times y dy dx. First take the integral with respect to y. This is your first integral. Then take the integral with respect to x. This is your second integral. Okay, one by one. The integral x squared to square root of x squared y dy. We are taking the integral with respect to y. X squared is just a number. This is equal to x squared y squared divided by 2. Y ranges between x squared to square root of x. So we plug square root of x, we plug x squared, we do the subtraction. This is equal to x squared times square root of x to the second divided by 2 minus x squared to the second divided by 2. So this guy, let me just write this up here to avoid any confusion. This is x squared times x over 2 minus x to the 4th divided by 2. This is my inner integral, my first integral. This is my first integral. Now I plug that in and start taking the integral with respect to x. So this is equal to the integral 0 to 1. The first integral has terms x in it. I get x cubed divided by 2 minus x to the 6th divided by 2 dx. The rest is easy. You've seen this integral before. This is x to the 4th divided by 8 minus x to the 7th over 14. X ranges between 0 to 1. So if I plug in 1, I get 1 over 8 minus 1 over 14. Here I can factor out a half. And then I can take the common denominator. Three divided by 56. I hope the calculation is correct. Let's see. Okay, let me see. Did I make any mistakes? Double check the whole thing. So here we have y. Did we do the multiplication? And this is x divided by 2, x squared, okay. Divided by 2, and then x cubed. And here I have x squared times y. Okay, I think seems okay. Well, give us another example. Let's go over another example, see what do we have. To leave these steps, follow these steps. If one of them is not given to us, we need to follow the steps. Now, so example.